Hello everybody. In this video we're going to cover the derivation of the surface area of a cylinder and the surface area of a sphere. However, for the derivation of the surface area of a sphere, we're going to have to make some assumptions because we are missing some tools in order to derive it from scratch. Okay, so let's get started. For this lesson, if you are able to go through all the questions here and understand all the content, then you should be able to complete the success criteria question, which you can do at the end. So let's dive right into it. So let's start with the derivation of the surface area of a cylinder. So first we consider a cylinder of radius r and height h. Okay. So again, the radius is distance from the center of the circle to the edge of the circle, and the height of the cylinder is just the height of the cylinder, how tall the cylinder is. And the first step in deriving the surface area equation, we need to draw a diagram that depicts the cylinder as two circles and a rectangle. So if you take a look at the cylinder carefully, you can see that there's two circular faces, right? The top and the bottom of the cylinder. And then in the body of the cylinder, you'll notice that if you unravel the body, it'll look like a rectangle. So that's the third shape. So here is shape number 1, the top face, shape number 2, the bottom face, and shape number 3, the rectangle, the body of the cylinder that's unraveled. Okay, and you also realize that the radius of each of the circles is going to be r. This is because the radius is r in our cylinder. And for the rectangle, you'll notice that the width of the rectangle is going to be h, because that corresponds with this h in the cylinder. And the length of the rectangle is going to be the circumference of one of the circles, because it takes that length to wrap around the cylinder. So remember the formula for the circumference is 2 times pi times r. So there we have it. We have the three shapes and its dimensions. So in the next step, we need to find the area of each of the shapes above. So for the first circle, if you remember, the area of a circle is pi r squared. For the second, the area is pi r squared. And then for the rectangle, it's length times width. So here we have length times the width. I'm going to rewrite this as 2 pi rh, because remember, if we have two variables next to each other, that's the same thing as multiplying. Okay. The next step, we need to find the total area of the shapes. So 1 plus 2 plus 3. That'll actually give us the surface area. So it's going to be pi r squared plus pi r squared plus 2 pi rh. I'm just going to simplify this a bit more. We have pi r squared twice, so that means we have two groups of pi r squared plus the rest of it, 2 pi rh. So in the end, the surface area of the cylinder is equal to 2 pi r squared plus 2 pi rh. Okay, and that's it. So let's put our surface area equation into practice in this practice question. Find the surface area of a cylinder that has a diameter of 10 centimeters. The diameter is 10 centimeters. And then once you see this, you can immediately calculate the radius. Remember, radius is half the diameter. And a height that is equal in length to its diameter. So the height is equal to the diameter, so that means height is 10 centimeters. So let's draw a little diagram to assist us in solving the problem. So here's my weird looking cylinder. So here, the height is 10 centimeters, And the radius from the center of the circle to the edge of the circle is 5, right? Centimeters. Okay. And then we can use the formula that we've derived above to find the surface area. So surface area is equal to 2 pi r squared plus 2 pi rh. Okay. So let me just double check that the formula is the same one as the above. Yes, it is. Okay. So then we substitute 2 pi. We substitute r for radius. Radius was 5 centimeters. 5 centimeters. So I'll just leave out the units for now. This is nothing. Let me just erase that. Okay. Plus 2 times pi times the radius, which is 5, times the height, which is 10 centimeters. So we can calculate this. This is 2 pi 25. 5 times 5 is 25. Plus 2 pi 50. I'll simplify this further. I can multiply the numbers together. 2 and 25, which is 50 pi, plus 2 and 50, which is 100 pi. And this we can simplify as 150 pi, because if you have 50 pi and 100 pi, well, 50 groups of pi and 100 groups of pi, then together you have 150 groups of pi. And the units for this is centimeters squared. You can multiply this out if you want. I like to leave it as this with pi in it, because I don't want to work with decimals. Okay, so let's move on to the surface area of a sphere. So we're going to derive this, but with an assumption. Okay, so let's start. A famous mathematician known as Archimedes found that the surface area of a sphere is equal to the surface area of the cylinder excluding the top and bottom circles that contains the sphere. So here we have the sphere, this blue sphere, and the sphere is contained in this cylinder. Okay. But this cylinder does not have a top face or a bottom face. Okay. So let's follow these steps below to find the surface area of the cylinder. The surface area of the cylinder first, and then using that we get the surface area of the sphere. So first we need to find the height of the cylinder. The height, if you realize, is not given, but we can deduce that the height is going to be 2r. That is because if you take the center of the sphere and find the length to the bottom edge of the sphere, that's going to be r, the radius. And if you take the length from the center of the sphere to the top edge of the sphere, we get r again. So the height of this sphere must be 2r, which is r plus r, right? So the height is equal to 2r, 2 times r. The next step is to find the surface area of the cylinder, excluding the top and the bottom. So if you exclude the top and the bottom faces, then you're excluding the 2 circles. We don't need that. We just need the rectangle part. So the width of the rectangle is going to be equal to the height of the cylinder, which is 2r given in the diagram. And then the circumference is going to be equal to the width. And remember, the circumference is equal to 2 times pi times r. And this is the circumference of one of the circles in the cylinder. Okay, so then the surface area of the cylinder excluding the top and bottom faces is going to be 2 pi r length times width, 2r. And we're going to simplify this. We're going to multiply the numbers together, 2 and 2, that's 4. and we're going to multiply the r's together. R times r, that's r squared. Okay. And that's going to be the surface area of the sphere, because that's the assumption we made at the beginning. The surface area of the sphere is going to be equal to 4 times pi times the radius of the sphere squared. Excellent. Okay, so let's apply this formula with this practice question. So if you have a sphere that has a surface area of 100 pi meters squared, what is the radius of the sphere? Okay, so on the page before this, we've discovered that the surface area of a sphere is going to be equal to 4 times pi times the radius squared. Here we're given the surface area, which is 100 pi. So I'm just going to replace that or substitute that in the equation. And we're trying to find this r here. What is this r? Well, on the left side we have pi, on the right side we have pi, so we can ignore the pi's. And then on the left side we have 100, and then on the right side we have 4 and r squared. So somehow these two, 4 times r squared, has to equal 100. So 4 times r squared is equal to 100. What do you think r squared is equal to? Well, it has to be 25, because 4 times 25 is 100. So if r squared is 25, what do you think r is equal to? R has to equal 5. Okay. So let me just show you how we would formally get the r here. In the next step of this, we would have to divide both sides by 4 pi. 100 pi is equal to 4 pi, because we want to isolate the r. Divide 4 pi, divide by 4 pi. So the next step we would get 25. 100 pi divided by 4 pi is 25. And then on the right side we're left with r squared, because 4 pi divided by 4 pi is 1. And then we want to get rid of the squared there, so we need to square root both sides. And this should give us the r. If you square root a square, you just get its base, which is r, and then the square root of 25 is 5. So we get the answer that r is equal to 5. So what is the radius of the sphere? The radius of the sphere, therefore, the radius of the sphere is 5 meters. Okay. So that concludes everything I want to cover in this video. Make sure that you understand all this. If you have any questions, please email me and try the success criteria question. If you're not able to do it, email me and ask for some clarification or some assistance. Okay. Thanks. See you next time.